Hello everyone. Today I'm going to demonstrate the usage of the RC4 encryption in REvil ransomware group and how the malware authors are utilizing the encryption algorithms to hide their malwares and perform some evasion techniques. So I will be started with what is the RC4 encryption. There are three different main stages in the RC4 encryption algorithm. The first one is the initialization stage. It is called as KSA. It is responsible to create a substitution box called as S box usually. And one of the best way to detect this and identify that as an RC4 encryption is looking at the iteration number. You can see that there is an iteration 256 and it is one of the giveaway to tell that this is an RC4 encryption. And after that stage there is a scrambling stage. It is called as PRGA. It is responsible to scramble the S box which was used in the XOR operation at the end. And these are a total three different stages. So let's go over to REvil ransomware sample and try to analyze this. So we will be assuming that it is the first stage malware, and we don't know which encryption type is used. We don't know is there any kind of packed sample or not. So we will be starting from 0. We will check out the entry point at first. I am using IDA freeware. You can also download this freely. So let's check out the first function. So when I see that function, I can immediately see a string over here, and it is being copied to the v5. I am assuming that this is some kind of key. So let's change this one to the key value probably, and there is v4, and we can see that it is an array with 256 byte of value, and there is an initialization going on in here. I think let's go over that one. So we can see that there are multiple loops going on. We can also observe the similar one over here. So these are, I think, the part of the scrambling phase. So let's give it a name, PRGA. Let's go back. Let's check out again. So this is using the key value. Let's go to another function. So this one is performing another loop. Let's synchronize this with the disassembler. You can see that it is looping through to that value. It is comparing the ESX. So let's convert this to the decimal, and this is the counter. Let's give it a counter 0. So it is going to iterate every single value inside this D word, which is, let's go over it. So this is the D word. It has been iterated until that value, and there is a modular expression going on as we observed in here. There are multiple modular expression and the for loops. It is using 256 value. and this one encrypted portion of the malware. It is a PE header, so it is inside the malware itself, and it is named as enc, which I think represent encrypted. So we can rename this as encrypted data, and at the end of the day there is a XOR going on over here. So let's try to copy this value and try to decrypt that. I'm going to use PE beer for the extraction of the section. Save it over here, and let's use CyberChef to decrypt the content. RC4 will be the algorithm, and this is the RC4 key. And here we go, it is successfully decrypt this section from the first REvil sample that we observed. It is containing an MZ magic header, which is indicating a Windows portable executable. I will save this as decrypted. .bin. Save it here. I will close this one and continue with the second malware, which is decrypted. So let's take a look at it. There's another way to detect possible RC4 encryption. I also wanted to show that in real quick. So we can use a tool named as Kappa or Kappa. I will try it out right now. REvil, V for the verbose, hit enter. So it is going to analyze the binary, and there are multiple rules. If the rule was matched, you can able to see that, hey, this function matches with the rule, for example encryption, RC4, PRGA, etc. And here is the match address. So you can basically copy this and go over to IDA and try to make some analysis. So let's try to do that in decrypted one. I will also show it how we can do it manually. So it is going to do the analysis. Let's see. So it is right now able to detect an RC4 encryption. So let's copy this address and paste it in here. So this function is probably related to the RC4 encryption. We can observe a while loop over here, and I am assuming that V4 is related to the S-box. I am going to rename this as possible RC4, hit X to see the X references. You can see that there is a V6 array. It is 256 byte value. I will rename it as S-box data. let's go over this one. And as you can see, this function is receiving multiple values from a PE header again, which is very similar to the first one that we observed. It is receiving from a PE header created by the malware author, and we can observe that it receives this one at first, and then there is another 32 byte value being received by this function. I am assuming that 32 byte is the number of the key length. Let's try to copy this, for example, and try to observe, is this a key length or not? I'm going to open up CyberChef again, paste the value. It is a hexadecimal value, so we are going to convert it, and here we go. It is right now UTF-8. I think it is, yes. So here's the output length. It is 32 byte value. Let's go here. So I think this one is the key, encryption key, and this one, which is far more larger than the encryption key, this is probably the encrypted data. I will check this one. Let's go to convert it as a decimal value. So this is the value. I think it is the length of the encrypted data. So let's also rename that length of the encrypted data. And now it looks much more better. This is, let's rename it as RC4. Here is the S box. Let's check out this one. I'm going to synchronize it again. So as we talked at the first, we can see that there is multiple loops. At total there are 2 different loops, and there is the creation of the S box and the scrambling stages going on, and we can see that the magic number, which is 2 for loop with 256 byte value. You can see the loop over here and another one over here. So I am assuming that this is the key scheduling algorithm, and this is the PRGA. So let's name this one as KSA cross-reference. The first one is the S box. We know it. The A1 is received from this function. Let's go back to see that. So A1 is encryption key. Let's rename it encryption key. This is the length, key length. This one is encrypted data. length of the encrypted data. Let's rename it like that. This one is the length of the encrypted data. And this is the result being put, yes, after the decryption. So there are multiple ways to get the encrypted data. The one way is to perform some debugging and put some breakpoint over here to observe the data being decrypted in memory, which require us to execute that ransomware on a machine. And another way to do that is doing the reverse engineering and finding where is the encrypted data, where is the encryption key. Since we already know that information, we are going to do that statically. I'm going to copy this value, export data. It is the RC4 encryption key. We already done that in here. RC4. I will delete this. And here is the encrypted data. So the encrypted data is very large. I'm going to select this by using a shortcut, Alt-L. So now I'm able to select data inside the address by using mouse clicks or just simply like this. So yeah, this one. I will export data, copy the value. Since it is from hexadecimal, we need to convert it. And here we go. We are able to successfully decrypt the configuration file inside the ransomware. Let's copy this one, go to Carbon. So here we go. I'm going to increase the size a little bit. We can see that in the configuration there is a public key which is used by the ransomware to do the encryption. We can see that debugging is false. There are other values such as there are some files, folder names. Probably they are passing those and doesn't make the encryption. This is used by other ransomware groups to increase the speed of the encryption. And there's, I think, base 64 encoded data. I will copy that and try to look at CyberChef. And we can see some string over here. I think it is the readme file. After the encryption has been done, threat actor basically use the readme file to get the money from a specific Bitcoin address, and they are telling you how to do that, what's happened, etc, etc. So that's pretty much it. We are able to now read the configuration file, which was encrypted 2 times, and they are using encoding algorithm base 64 to hide this string value to evade some detection. So as a quick summary, we used the first REvil ransomware binary, and we identified that there is a section named as enc, which is encrypted, and we identified that they are using RC4 by using a magic number used by this algorithm we observed. And then we successfully decrypt this section from the binary and receive the decrypted binary, which is the unpacked version of the REvil ransomware, and then we received another section on the decrypted, this one, and then we also identified they are using same exact algorithm to decrypt this section, the RC4 algorithm being used to decrypt this section, and then we received the configuration file successfully. Thank you very much for your listening.